Alright, so where we left off was this header file here. So now we're ready to actually start writing our code here. So, one other thing I was going to do here, if you want to see what this is here, if you Google, this one's dead here, this window. Let's go here, and you could always Google, not literally Google there, extern, and then you can even see the first one thing here is what is the effect of extern C and C++. And so extern makes a function have a linkage code so that the client can use link. I don't like that description there. There, let me say extern variable in C. Let's see what happens. There we go. Understanding keyword extern. So understanding, I'm sure we're supposed to interested in C virgins, haha. Keyword applies, and so you can go on and continue reading this. So, but I'm not going to read it for us right now. We're going to go back to programming here. Alright, so what we need to do now, of course, is we need to add a new item, and it needs to be a C file, and then it should be the same name as the header file, MPL115A2.C. So I've got a C file opened here, and I'm just going to go to my header file at the top here and just kind of copy and paste this here. Okay, so the first thing here we should have is our includes for header files. So include, well, one that should be obvious that you're going to want to include is the H file. One that's not necessarily as obvious. Because I did make it capital. And there we go. And let me rename this one to all caps as well. MPL115A2.C. Alright. But the other one we want to include here, because we're going to need access to the API for the I2C bus, so I'm going to want to include the project.h. Now this is where, depending on what application you're using this for, you might have to modify the headers, because if you're using this API for a different thing besides PSOC, or if you have a different header besides project that contains your APIs for the I2C, you would have to include those, because we needed access to the I2C devices. Alright, and then I'll put here global variables, because I need some global variables, and those were ones that we have here. But you're going to notice that once you have a good header file developed, we get to copy and paste a lot of this stuff into the C code. So I'm going to copy and paste some of this, and then I'm just going to define these here. And while it's technically not necessary to do this, I'm going to define them all equal to 0. I like to define them all equal to 0 because then I know what's in them to start with. I always like having predefined variables. It's not necessary to, but I think it's a good practice. And it's not that you need to predefine them as 0, predefine them as something that makes sense in your coding. In this sense, 0 makes sense because I'm going to be loading data in. I'm going to be ORing this. And if I'm ORing data with 0, that's great. Alright, so then we also have our API functions then. Well, again, I'm a big fan of copy and pasting because we need to make sure that our functions match the names of our APIs. So I'm just going to literally copy and paste my function prototypes. Now we're going to have to do a little bit of adjustment on them. And one of the things we have to adjust here is taking the semicolons out and then actually making these functions. Now I know it's not going to be happy with us right now. It's going to give us warnings and errors and stuff like that. Well, it's actually just all warnings, because basically it's saying, hey, you're supposed to return a variable and you never did, or return a number and you never did. So, well, we have no code there. And this is saying, hey, you know, unused parameter press, and then it's also got an unused parameter temp. You know, well, of course we haven't written any code yet. Now technically you could do the code in any order, but we're going to go ahead and read the coefficients in first here. So my opinion is you should write a fairly good description here, although you can avoid writing a good description here. And what we're going to do is we're going to practice what Cypress has done with their data sheets, is create an API section of the data sheet to explain what the API functions are that we've created for this. So the one thing I'm going to put here, though, to emphasize is that user must start the I2C component before running any API functions. And what we mean there is we need to have some kind of, we'll say, well, because of what we've named it here, I2C underscore I2C actually, let me think, what is it here? I'm putting a comment in there, I2C underscore, it is I2C underscore I2C start, I believe. Nope. I2C master, if I can type. What's going on here? I2C so I didn't think there was anything. There we go. And I'm gonna, because we're not gonna actually do that. It says user must execute this command before API things, and we also say here the I2C component must be named I2C. Now technically it doesn't, but you would have to go in and modify this code, and once we get some code written, I'll tell you what we mean there. Alright, so let's go ahead, and actually the longest function we're going to have to write, believe it or not, is the start function here. So we'll make a video just for the start function. So we need to read in my coefficients here. Well, if we look at the data sheets here, the way that these things are read in is that we're going to need some integers here, because I'm going to put data read, but this needs to be an unsigned int 8-bit integer, and I'm going to again initiate this as 0, and then we're going to eventually cast these as floats, but for now what we're going to need is we're going to need int 16s. Actually, you could probably do unsigned int 16. It doesn't really matter, I don't think. But then I'm going to do, now I'm not going to worry about doing the MPL, maybe I will, MPL 115, do I want, yes I do, MPL 115 A2 underscore A0. And I'm going to define that to be 0 to start with. And then I need 3 more of those. And so this is what I'm going to store the data in, because when I'm reading the data in, I'm just storing it in integers, then I'm going to convert it to the floats by casting it properly. Alright, now the first thing here we're going to do is set pointer to correct register, because we want to start reading data in, but we have to first set it to the correct register. So we're going to do I2C master, except I keep forgetting there's no space there, master send start, and then we're going to put in the slave address, but this is where it's nice having these macros. You don't have to remember what that is, you just put it in there. Whether we want to be in read-write mode. Now you can remember those, what they are, like 0 is write, 1 is where is it? Here we go. 1 is read and 1 is write. And it's yes, it's a long thing to type in, but again, the reason, and you can see here I hover over and it's just a 0 sitting in there. But again, the reason I like this here is because it allows me to have functions to me that instead of just having random numbers in there, it makes a little bit more sense. So I can see that, oh, I'm accessing the MPL115A2 and I'm putting in write mode. Now, there's one other thing we have to put in here, is we have to put in a timeout in milliseconds. Now if you look at the API here, I'm going to actually then do a macro up here, and I'm going to just say inf delay 0x00. And here, I'll put an underscore under that. And that means if you put 0 in here, you get an infinite delay. But again, it's kind of nice to at least, I mean, if you put a number in there like 3, I mean, that would be okay. I'm not saying that you should put in and create a macro for every single delay time. But if you put a 0 in, that means it's going to infinitely delay, in the sense that, if I spelled delay correctly, and it looks like it's not, oh, it's because I haven't put a semicolon there yet. And what it means by that is it's not going to time out. So it's going to just wait for this code. Now, you know, that's not necessarily a good idea to do, but in this code, I know this device works it's a very stable device, it works fine, and we're going to do that here. And other things you might want to actually have, like, oh, after, you know, 100 milliseconds, it's going to time out. And then this I2C actually has, you know, we could put here, I'm not going to look at it right now, but we could put here, for instance, int error equals this, because it sends an error code back. And so we can see there's a table in the data sheet to say, okay, if the error code is 0, that's a successful start. If the error code is 1, this is what's happened. If the error code is 2, this is what happened. You know, so we can see if there's an error, what's going on with that. But again, for us, we're not going to bother with that right now. All right, then remember we have to actually write a byte, and the byte we want to write is the register address we want to read from, because we have to set the pointer. That's what we're setting here. And the first thing we want to read is the MPL115 A0 not least significant byte. We're going to want the most significant byte. And then again, we're going to do an inf delay for the timeout. And then actually that is all we're going to do here. Now technically you don't have to do a send stop. You can have your next one be a restart command, but I like using the send stop. And I forgot to put in a delay here. I like using the send stop because if we're done with the program at this point, we want to make sure that the buses, other APIs don't have to think, oh, I have to issue a restart command as my first command. You want it to make sure that the first command other APIs would be issuing is a send start. So that's why I like to use the send stop. All right, now next thing we're going to do is read the data, or I should say read the coefficients in. And actually I'm going to go ahead and do a little bit of copying and pasting here because these commands are almost the same here. So I am going to do a send start, but instead I'm going to put it in the read mode, and instead of writing a byte, I'm going to read a byte. And I'm going to move this send stop a little bit down here. Now I have to do the read byte correctly here, so I first put in let's just delete this out here so we can see here. I have to first send some kind of acknowledgement here, and I2C underscore I2C, and I cannot type right now. And you can see there's an acknowledge for data, so that's what we want to put in, saying okay, we acknowledge that we received the data, and then we have to put in a pointer for where we're storing the data. And notice here, if I bulk out, it's an unsigned int 8, which is why I defined it as an unsigned int 8. So this is going to be data read, and then another timeout, so we'll do an inf delay. Alright, so now this reads in the most significant byte here. Now fortunately the pointer automatically goes to the least significant byte, but what we have to first do here is we have to do a little bit of bit shifting, because if I just do for instance MPL115A0 equals data read, which is fine, we are going to do that. What that does is it puts those in the least significant spots. In other words, MPL115A2A0 is a 16-bit integer. Data read is an 8-bit unsigned integer. It's going to take those 8 bits and put it in spots 7 to 0 in that variable. But this is the most significant byte, and we want them in spots 15 to 8. That's not a hard thing to do. All we have to do is bit shift it, and I'm sure there's a quicker, slicker way of doing it than this, but this is the way I'm doing it. And so I need to move it 8 spots to the left, and this double here kind of arrow thing is bit shifting, and it's saying, hey look, it's going to the left. So I'm done. So no, I'm not done with this. So I need to now read in another piece of data, and what I need to do here is I need to, because these are now spots 0 through 7, so I want to OR equal it, because I want to do MPL115A2A0 ORed equals itself ORed with the new piece of data that I read in. Okay, so now I have the most significant byte read in, but let's go back to the data sheet real quickly here, and we can see here that we have integer bits and fractional bits here. So we need to make sure that we account for that, and so we have to divide by the correct number. And since we have 3 fractional bits, we also have 1 sign bit here, 12 integer bits, 3 fractional bits. So I want to convert this so I can actually store this finally in my global variable. This is going to be equal to MPL115A0, but I need to cast this as a float, because that's what it is, and then I'm going to divide it by 2 to the third power, which is just 8.0. Now, you might want to put in some comments on why we're doing that. I'm just going to put in here read A0. You might want to put in some additional comments for yourself. But now we're essentially going to just, oops, what did I forget here? I forgot the semicolon. Now we're just basically going to somewhat repeat this for the next 3 variables that we need to read in. So I am going to do some copying and pasting here. Now you have to be careful when you do copying and pasting and making sure that you actually change the things you need to change. So this would be, thinking about it, this would be reading not A0, this would be reading B1, this would be B2, and this would be C12. And so I'm going to have to change variable names here. I'm still reading it, so this would be B1, 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 this would be B1, B1, make sure I change the right one here. Yeah, sorry about that. This would here be B1. And then we would divide it by 2. And now you might want to do this kind of thing. That won't work. It gives you an error. Because remember, you have to actually use a function in the math library, which you could read in the math library if you wanted to, and you have to use a POW, P-O-W for that. So remember, things don't just work as your, and it's not 2 to the 8th, it would be 2 to the, if we go back to the data sheet here, whoops, that's not the data sheet, it'd be 2 to the 13th. And so, get back to my code, here we go. This would be like 2 to the 13th, 2.0 to the 13th power. Now it's still going to give you an error because it hates you, because this isn't a calculator, this is code, and so you'd have to use like the POW function. And it doesn't have it there because you don't have the math library included. Now you could include the math library if you wanted to, or you could just simply use a calculator and say what is to the 13th here. Now if you get really big numbers, of course you wouldn't want to do this. So it's 8,192. $8,192.0. And actually I'm going to go ahead and copy this over top of the B2 stuff, because then reading in B2, all I'm doing is changing these to B2. Now this is again where you have to be careful. You need to make sure that you changed everything. And then this would just be, I mean, you could actually probably do a parenthesis here, 2 times, because we have just, it's 2 to the 14th power. And just to make sure, I always like to, when I'm doing floating points, I always like to make sure that I do 2.0 as opposed to just 2 here. Or you could figure out what that number is, which is what, 16. Math not working for me right now. Times 2, 16,384. So you could also do 16,384. All right, so now we have the C12 here. So we're going to first just change everything to C12, and then we're going to have to look at the data sheet here to see, because C12 is a little bit different here. Okay, so reading in C12. What I mean by C12 being a little bit different here, first off, total number of bits is 14. And notice how it has it read in here. So I'm going to put a comment here just so that we know. I'm going to put a comment here. MPO115A2 currently has C15, C14, C13, C12, C11, C10, C9, C8, C7, C6, C5, 4, 3, 2, I'm sorry, it's not 14. I'm not following what the thing says. It's 13. So we start with 13 because it's a 14-bit number. C2, C1, and C0, and then 0, 0. That is what's currently stored in the variable. But the problem is I don't want these zeros here. I don't want these I don't want these zeros here. What we want this. Now, if we think about what we've been doing here, this should be a very simple thing for us to do. Well, because if I want to, I'm just moving the whole thing equals MPL115 underscore 115 A2 underscore C12 bit shift it 2 spots to the right. That's all we ended up having to do. Now, this is where we're going to get into a little bit thing here. It's like, okay, we have to figure out what we have to divide it by. Well, it says it's got 13 decimal bits, no integer bits, and 9 decimal point 0 pad. That means we need to divide it by 2 to the 22nd power. So we need to do 2 to the 22nd power. 4194304. Let me just double check that. 4194304. Now, at this point, I'm just getting a little lazy. I really probably should at this point install the math library and do these mathematically using the PAL function, because now they're just becoming big numbers. And there's other ways to do this. You can do it by bit shifting as well, but I just like doing the dividing by the number. Okay, so that's it. We have them read in. And that's where we're going to stop this video.